Welcome or welcome back. So this is a third video about inference about two means when we have independent samples. In this video I want to focus on confidence intervals for the difference in means and with a little bit of context. So in this example, a study was conducted to see if carpeted rooms contain more bacteria than uncarpeted rooms in a hospital. So we've got some data from carpeted rooms, and this is uncarpeted rooms, and to determine the amount of bacteria in a room, researchers pumped the air from the room over a petri dish at a rate of 1 cubic foot per minute for 8 carpeted rooms and 8 uncarpeted rooms. Colonies were allowed to form, and then this is bacteria per cubic foot in each of these. So that's kind of the background there. All right, so we're going to use construct a confidence interval, and also I want to show you, remind you of how you can use a confidence interval for a two-tailed hypothesis test. So let's just say right up front that what we're interested in is whether these are the same or different. So we're going to conduct a two-tailed test, and let's use 1% for alpha. So we're going to conduct a fairly strict test. So first of all, I want to construct the confidence interval for this. So I've written down the formula that we use to construct this confidence interval. I would take the sample mean from group 1 and subtract the sample mean from group 2. And then for a lower bound, I would subtract what follows here, which is t of alpha over 2, and then the standard error here is s1 squared over n1 plus s2 squared over n2. So certainly this can be done by hand. You would have to use an inverse t function to find this critical value for t, but I'm going to do the confidence interval in my calculator. So let's see. This is going to be found in the stat menu under test, and I want a two sample t interval, and so that's here, and in this case I actually have the raw data, so I'm going to change that from stats to data, and I've already entered this data in list 1 and list 2, and for confidence level I'm just going to change this. Since I said a 1% significance level, that would be a confidence level of 99, and I'll hit calculate. And I find that I get a lower bound of negative 3.009 and an upper bound of 5.8337. So this is a confidence interval for the difference in mean. So it looks like the difference between the means from these carpeted rooms and uncarpeted rooms is somewhere between 3 and, let's just say this is 6. And again, the units there I think were bacteria per cubic foot. So there seems to be that the difference between carpeted and uncarpeted rooms is somewhere between -3 and +5. Well, what would a negative difference mean? So in order to calculate this, I'm looking at mu1 minus mu2. So if that's a negative value, it means that this is bigger. So there would be more bacteria in uncarpeted rooms. However, if the difference is positive, that would mean mu1 must be the bigger value. In other words, there's more bacteria in the carpeted rooms. Well, it looks like I can't be sure. I have an interval that spans from a negative number to a positive number, and so that certainly includes 0. Well, if my confidence interval includes 0, it's very possible that the means are the same, so that difference would then be 0. So if this interval contains 0, then I think that there's a possibility that these are the same, and so I'm going to fail to reject the null hypothesis, which would mean there is insufficient evidence that these means differ, so that the mean bacteria count is different in carpeted rooms and uncarpeted rooms. Now, of course, just like with the t-test that I've done in other videos, we should check some conditions and make sure that since we have small populations here, our sample size here, which is, what is it, 8, and here as well, those are relatively small samples, so I might want to check to see that these are normally distributed. You could do that using a box plot. So if I go to my stat plot menu and then use the box plot option and look at list 1, I don't see any outliers, and this looks fairly symmetric. I think I'm good to go. I should check this for the other list as well. So change this to list 2, and yeah, again, I think we're good to go. So with that being said, we fail to reject. So there's insufficient evidence of a difference, and just to kind of show you how this compares when we using this method as opposed to the t-test method. If I did the 2-sample t-test, option number 4, with the data in list 1 and list 2, you notice I get a p-value of about 36%, which I would have rejected using that method as well. So here's how you can construct a confidence intervals for the difference, and then how you can use that to conduct a hypothesis test when it's a two-tailed test. So if 0 is in your interval, you will fail to reject. All right, hope that's helpful.